Hello, dear students. Welcome once again to our online class. This is Johurul Islam with you. Today, I'm going to discuss about a very simple creative question of chapter 11. So, let's have a look. What is today's creative question? This is question. This circuit is the main stem of this question, and there are 5 resistances is present here, and the value of R1, R2 and R3 resistances is 5 ohm, and the value of R4 and R5 resistance is 10 ohm. The question number C said that determine the equivalent resistance of the circuit, and question D said are the value of I3 and I5 current same? Analyze mathematically. So dear students, let's have a look how can we determine our equivalent resistance of the circuit. Dear students, before going to determine the equivalent resistance of the circuit, I am showing here 3 circuits. These 3 circuits actually the equivalent circuit of this main circuit, but you do not need to necessarily to draw this circuit. I am drawing this circuit to make you understand what will happen in between the circuit. Okay, dear students, let's have a look. You are seeing that the R1 and R2 resistances are series resistance here, series combination, and in this case R3 and R4 resistance also series resistance, and that combination R5 will be the parallel. Okay, with the combination of R3 and R4, R5 resistance are parallel. So, dear students, if you consider the equivalent resistance of R1 and R2 is RS1, then if you consider the equivalent resistance of R3 and R4 is RS2, then what will be our next circuit? This will be our next circuit. Dear students, here the equivalent resistance RS1, which is the equivalent resistance of Rn and R2 resistances, and the equivalent resistance RS2 is the equivalent resistance of R3 and R4 resistances, and the R5 resistance is present here. Now look at this picture. This picture, that means this circuit is the actually equivalent circuit of this circuit. So now look at this circuit. Here RS2 and R5 are the equivalent resistances. So as RS2 and R5 are equivalent, sorry dear students, RS2 and R5 is parallel combination. As RS2 and R5 is parallel combination, that's why if you consider the equivalent resistance of RS2 and R5 is Rp, then you can write Rp here instead of RS2 and R5. So the equivalent circuit of this circuit will be this. Now you can see that RS1 and Rp resistances are in series. Now if you consider the equivalent resistance of these 2 resistances is RS3, then you can write here RS3. So this circuit will be actually the equivalent resistance of this main circuit. So dear students, in our previous lesson we have already seen that if we determine the current of any complex circuit or any mixed circuit, we have to convert that complex circuit to the simple circuit, and this is our simple circuit. So dear students, if you determine the current of this simple circuit I, that means this current will be that current. Okay, dear students, now we can determine this current. So you do not need to necessarily to draw this picture. I am drawing here just to make you understand. Okay, dear students, now let's have a look how can we determine the equivalent resistance of the circuit. You can write in such way, as R1 and R2 are in series combination, and if the equivalent resistance of this combination is RS1, then we can write here. First of all, you will write in such way, as R1 and R2 are in series combination and if the equivalent resistance and if the equivalent resistance of these two resistances is RS1, then we can write RS1 is equal R1 plus R2. So the value of R1 is given here 5 ohm and R2 is also 5 ohm. So 5 ohm plus 5 ohm, you can write 10 ohm. So dear students, the value of RS1 is 10 ohm. Now we can determine the value of RS2. So again you can write here as you can write again as R3 and R4 are in series combination, and if the equivalent resistance of this combination of these two resistances is RS2, then we can write RS2 is equal R3 plus R4. Dear students, the value of R3 is 5 and the value of R4 is 10. Dear students, the value of R3 is 5 and R4 will be 10. Okay. Now, the total equivalent resistance will be 15 ohm. So, dear students, the value of RS2 is 15 ohm. Now, as RS1 and RP is in parallel in series combination, dear students, RS2 and R5 are in parallel combination. So if the equivalent resistance is RP, if the equivalent resistance of these two resistances is RP, so we can write in such way. You have to write all these things that I have said, but I don't write now. I cannot write now as the time is very short. So you can write here. As the equivalent resistance is RP, so you can write 1 by RP is equal 1 by RS2 plus 1 by R5. Okay, so you can put the value RS2, the value of RS2 is 15 plus the value of R5 is 10 ohm. So dear students, what will be the result? The result will be the LCM is 30 ohm. So you can write 2 plus 3, that means 5 by 30 ohm. Dear students, 1 by RP is equal 5 by 30. So you can write RP is equal 30 divided by 5, that means 6 ohm directly. So dear students, now the circuit will be this. As RP is 6 ohm and RP and RS1 are in series combination, so if the equivalent resistance is RS3, so you can write RS3 is equal RS1 plus RP. The value of RS1 is, dear students, the value of RS1 is 10 ohm and the value of RP is 6 ohm. So total equivalent resistance of this circuit is 16 ohm. This is RS3. So dear students, you have to write all these things that I have told here, but in case of short time, that's why I cannot write here all these things that I have said. So dear students, the equivalent resistance of this circuit is 16 ohm. Now I will determine the current of I3, current which is passing through the R3 and R4 resistance. Dear students, the current which is passing through the R3 and R4 resistance, that means I3, and the current which is passing through the R5 resistance, that means I5. So dear students, before determining the I3 and I5 current, you have to determine the main current of this circuit, because this current will divide it into two parts, which is I3 and I5. That means when the main current of this circuit is reaching this point, then after reaching this point, this current will be divided into two parts. One is I3, which is going through the R3 and R4 resistances, and another is I5, which is going through R5 resistance. So you have to determine first the main current of this circuit. So dear students, what will be the main current of this circuit? And you will remember this, the equivalent resistance of this circuit is RS3, which is 16 ohm. So the solution number D, you have to determine the main current of this circuit. You know that I is equal E divided by R. In this case, R will be the RS3. So you can write RS3. If internal resistance is present here, then you can write RS3 plus small r. But as the internal resistance is not present here, so we cannot write RS3 plus small r. It's not necessary to write the small r. So the value of E is given here 20 volt and RS3 is 16. 20 volt divided by 16 ohm. The value of I current will be the 1.25 ampere. Okay, dear students, this is the value of main current, 1.25 ampere. Now, dear students, this is our main topics in case of when current is passing through this circuit. Then after reaching this circuit, the current will divide it into two parts. So how can we determine that two currents? That means the I3 and I5. So dear students, the I current is going through this circuit. That means I current is going through this circuit. Same. So when I current is going through this circuit, that means I current is going through this circuit, as this circuit is the equivalent circuit. So when I current will going through this circuit, then after reaching this point, it will create a voltage difference between RS1 resistance and RP resistance. So if you determine the current I3, that means the current which is going through the R3, R4 resistance, in this case I3 will be, in that circuit I3 will be here, I3. That means I3 is going through RS2, that means I3 is going R3 and R4 resistances. And I5 will be here, I5. As I3 and I5 current is going divided into two parts in this case. So dear students, I current is going through this circuit, that means I current is going through also this circuit. So if you determine the I3 current and I5 current, you have to know as I is equal V divided by R. You know that, dear students, you know from Ohm's law, V is equal IR. That means if you determine any current which is going through the R resistance, that means this resistance, then you have to remember that you have to determine first the voltage difference between these the two terminal of this resistance. So dear students, as we determine the I3 and I5 current, I3 current which is going through the RS2 resistance, so we have to determine first the voltage difference between RS2 resistance, that means this resistance RS2, and as we determine the current of I5, so we have to determine the voltage difference between R5 resistance. So dear students, how can we determine the voltage difference between R5 and RS2 resistances? As the equivalent resistance of RS2 and R5 is RP. So if you determine the voltage difference between RP resistance, between two terminal of RP resistance, if you determine the voltage difference between two terminal of RP resistance, then you can say that voltage difference will be the voltage difference of RS2 and R5 resistance, as the RS2 and R5 resistance are in parallel combination. And we know that in case of parallel combination, the resistances which are in parallel combination, the voltage difference between two terminal of that resistances, that means of each resistances, will be same. So dear students, if you determine the voltage difference between between two terminal of RP resistance, then you can say that voltage difference will be the voltage difference of RS2 and R5 resistances. So you have to determine first the voltage drop or the voltage difference between two terminal of RP resistance. So dear students, if you consider the voltage drop or the voltage difference between two terminal of RP resistance is Vp, so you can write Vp is equal IRP, because I current is going through the RP resistance, so you can write voltage Vp is equal IRP. So dear students, as the value of current is 1.25, so you can write 1.25 ampere, and the value of RP is 6 ohm, so you can write 6 ohm. So what will be the value of Vp? The value of Vp will be 7.5 volt. 7.5 volt. Okay dear students, we can already determine our voltage drop, voltage difference between two terminals of RP resistance. So as the Vp is the voltage difference between two terminal of RP resistance, so this Vp will be the voltage difference between these two terminal, because these two terminal meaning the same word of these two terminal. So dear students, now we can determine, so we can write Vp is equal I3 RS2 and Vp is equal I5 R5. Okay, so let's have a look. Now we can write, now Vp is equal I3 RS2, or you can write I3 is equal Vp divided by RS2. The value of Vp is 7.5 volt, 7.5 volt, and the value of RS2, dear students, RS2 will be the 15 ohm. So it will be the 0.5 ampere. The value of I3 will be the 0.5 ampere. So now again we can determine the value of I5. So again we can write here, again we can write Vp is equal I5 into R5. So I5 will be Vp divided by R5, and the value of Vp is 7.5 and the value of R5 will be 10 ohm. So the value of I5 will be 0.75 ampere. So dear students, we have already seen the value of I3 is 0.5 ampere and value of I5 is 0.75 ampere. So in this case, are the value of I3 and I5 current are same? No dear students, the value of I3 and I5 current are not same. So this is our answer of this question. So dear students, this is a very simple and very easy circuit. If you determine if you can understand this circuit, then you can solve any complex circuit. So dear students, you should remember, you have to understand this type of simple circuit, then you can easily solve any complex circuit. So dear students, this is our today's lesson. Thank you for this moment. Thank you. Allah Hafiz.